Right, so then we move on to this last family tree kind of image here, and again, just another perspective of how far away we were from the origin of life to the origin of us, or very, very complex eukaryotic organisms, was. So pretty much what you can see is mammals there. We're looking at some 250 million years ago when the first mammals actually came about, and we're a derivative of them. Before then it was basic birds and reptiles, amphibians and things like that. And so really we're looking at any kind of eukaryotic organisms, going all the way back to what we would say, over 1,000 million years ago or 1 billion years ago. And so then we go far out. Bacteria actually were able to survive, grow and do all these things for double that amount of time before anything else actually even came about that was slightly more complex. And then it was still over another 750 million years before it sort of began us, so that the origin of divergence into us. So it really puts into perspective how far removed we are from the origins of a single cell or single-celled organisms. But also that they've been able to continue to grow and to continue to thrive and multiply and exist for that whole time. And we are really just basically 65 million years old in essence, I think, not even that. So yeah, just very perspectively, such a long time and such a big time period for minimal amounts of life to exist. Well, I shouldn't say minimal, but I should say minimally complex life to exist. The next thing we're going to have a look at now is this RNA world hypothesis and some other underpinning hypotheses that suggest that, from simple things we could have originated eventually. And so we're going to have a look at a basic experiment that was done in the 50s, so I think it was 1952, by a couple of key scientists to go look, if we've got inorganic materials, can we actually create organic matter as a result? And so there was this experiment done, like I said, in 1952, the Miller-Urey experiment, where what they did was they created this closed vessel, so a chamber that mimics basically an atmosphere like we would have here. And they had water, ammonia, methane, I can't remember if there's anything else in there, but some basic compounds, so inorganic compounds, so non-living things. And they said, if we actually replicated conditions like there would have been potentially on Earth back then, would natural or organic compounds start to form spontaneously and therefore be able to support this idea that life originated from non-living things? And so basically 1 week within this experiment was what they did was they were heating up the water that existed in this vessel. They also added a power supply to mimic and some sparks to mimic lightning. And what happened was all of those ingredients were able to come together and start the formation of things like amino acids, sugars, lipids, and the basic building blocks of nucleic acids, which inferred or supported that from inorganic materials we can start to get organic things, or the early predecessors for organic matter being formed. So it really validated this idea that we could grow from nothing or from non-living things if the right conditions were met. So there's more on that here that you can watch, and as again, I always advocate to watch these videos. We're now going to look, the one before is an RNA world hypothesis one. So this is now moving on and suggesting that RNA existed before DNA, and again, something that was mostly spontaneous, so that when basic nucleic acids could have formed, such as RNA, ribonucleic acid, what would happen is we might get this natural or spontaneous amalgamation of a membrane to help protect RNA if there was water there. And so this is what we know now, what we see, and we talk about cell membranes in eukaryotic organisms. When we do our cells unit, is we say that our cell membrane is composed of a phospholipid bilayer, and we've got the hydrophilic and hydrophobic ends. Now, theoretically, if we've got phospholipids all floating around, and then, or just existing, and then we add water, and there's all this ribonucleic acid, and there's water there, the phospholipids are going to naturally form